using recursive formulas for arithmetic sequences. Some arithmetic sequences are defined in terms of the previous term using a recursive formula. The formula provides an algebraic rule for determining the terms of the sequence. A recursive formula allows us to find any term of an arithmetic sequence using a function of the preceding term. Each term is the sum of the previous term and the common difference. For example, if the common difference is 5, then each term is the previous term plus 5. As with any recursive formula, the first term must be given. A subscript n is going to equal to the previous term, a subscript n minus 1, plus the common difference, where n is greater than or equal to 2. So again, the recursive formula for arithmetic sequence, here is the recursive formula for an arithmetic sequence with common difference d. So there is our recursive formula for an arithmetic sequence. Now, given an arithmetic sequence, we want to write its recursive formula. We're going to subtract any term from the subsequent term to find the common difference. 2, we're going to state the initial term and substitute the common difference into the recursive formula for arithmetic sequences. So for example 4, we're writing a recursive formula for an arithmetic sequence. So here's our sequence: negative 18, minus 7, 4, 15, 26. So the first term is given as negative 18. The common difference can be found by subtracting the first term from the second term. So d is going to equal negative 7 minus negative 18. Well, this becomes negative 7 plus 18, which is positive 11. So we can see here that the common difference is going to be 11. And now we're going to substitute the initial term, which we found to be the first term, which is negative 18, and the common difference, which is 11, into the recursive formula for the arithmetic sequence. So again, this is the recursive formula, a subscript n, which is equal to a subscript n minus 1 plus d, for n is greater than or equal to 2. So we would have a subscript n, which is going to equal the first term, a subscript n minus 1 plus 11 for n is greater than or equal to 2. So this is going to represent our recursive formula for the arithmetic sequence according to the numbers that were given in our example. So we see the common difference is the slope of the line formed when we graph the terms of the sequence as shown in figure 3. The growth pattern of the sequence shows the constant difference of 11 units. So it's going up 11 over 1, up 11 over 1, up 11 over 1, and then up 11, and then over 1. Now, question and answer. Do we have to subtract the first term from the second term to find the common difference? The answer is no. We can subtract any term in the sequence from the subsequent term. It is, however, most common to subtract the first term from the second term because it is often the easiest method of finding the common difference.